firstly, like right now, what are the vertical asymptotes? Oh, can we do, like, before we do that, can we do like a little, real quick review? So this is separate here. What's the vertical asymptote on this? 0. What's the horizontal asymptote? What was it?
It was -3.
No, on the other, not the one we were doing. This example problem, 1 over x.
Oh, 0.
All right, so how do you know it's 0?
Top degree is less than bottom degree.
Okay, so is there any vertical asymptotes on this one? What? So 2 is 1. Is that the only one? 2 and 0. Okay. What about horizontal asymptote? 0. Okay. Any questions so far? What about vertical asymptotes now? Is it still 0 and 2? Okay, what about horizontal asymptotes? Still 0. What about vertical asymptotes right now? Okay, still 0 and 2. What about horizontal asymptote? I don't know. Is there? Why is it 1?
Because it's another word.
You guys said A over B up there. So the degrees are the same, and so you guys say A over B. What's A over B?
1 over 1.
1 over, oh, so, well, yeah, in this case it's 1 over 1, but in general, A and B are what? Like, just in general? Yeah, okay, so the leading coefficient, okay. All right, what about vertical asymptotes now? What is it? You're doing the wrong one. Just 2. Why is it just 2?
Because you can cancel out the x.
Because we can cancel out the x, and now we only have one vertical asymptote at 2. Okay, what about the horizontal asymptote?
There is
Why is there none?
because the degree on the top is higher than the bottom.
What is the degree on the top?
3.
3. How did you get 3?
Well, it's x plus 3 squared, and then you have an x on the outside.
Okay, so like if you squared x plus 3, you'd get x squared plus whatever, and then you'd multiply x squared by x by distributing, and so then x to the third. Okay, is that okay with everyone? All right, what if I, one more of these. And what is the, oh, maybe 2 more of these. What is the vertical asymptotes? There's 2 of them still. What about the horizontal asymptote?
Would be 8.
Because,
8 divided by 1.
okay, what about the horizontal asymptote now? 4. Is that okay with everybody? Does anybody have questions on any of this? Okay, so now let's go back to that. Okay, so we got ourselves to here, and we started with the vertical asymptotes, and we got an x and then x minus 5 halves. And so what are our vertical asymptotes now?
0 and 5 halves.
0 and 5 halves. Why did we have to add the -1 in order to get the vertical asymptote?
Keep something canceling. Yeah.
To keep things from canceling out. Okay, so you should, maybe you still have this in your calculator, but put that back in, and then, because the other thing was that we were supposed to get a horizontal asymptote at -3. And so now, is your horizontal asymptote at -3? No, it is not. So what is the problem then? Because do we have the same degree? We do. And what's our lead coefficient of the top? So then, what is the what must the lead coefficient in the bottom not be?
Any number other than 1.
So it must be something other than 1 right now, because otherwise we would have the horizontal at -3. Is that okay with everyone? Well, then what's the lead coefficient down there then? Well, how can we figure out what the lead coefficient is if it's, like, what can we do?
We can distribute it.
All right, let's try to distribute it then, and then so that we'd have,
Get that in.
so that's what, if you distribute it. So it still seems like it's 1, but if it was 1, we'd have a horizontal asymptote at -3, so it must not be 1. So I guess what I would ask you is this a normal looking factor?
No, you do the thing where you
You do 2x and x on the side.
Yeah, really, what you would normally get right would be, this would be the same, these are equivalent, right? So then what is our lead coefficient then? 2. So then how can we change this so that we have a horizontal asymptote at -3?
Multiply by 2.
So, well, we're just going to change something. So like, what should our, let's leave our denominator the same. Let's just leave it as,
So the top needs to be -6.
all right, so then try it out, put it in. Put it in and see, put it in and see. Does it look good? If you can't tell, why don't you go to the window and go change the x min to -100 and the x max to 100, and then retell me if it looks better that way. Right, it should be a little easier to see that it's zeroed in there on -3. Is anybody not seeing that? Read the directions. How many people think they know what the directions are asking?
And exercise.
It's just like, what is it, what number is it?
I looked at this last night and I had no idea. Get fancy.
Well, okay, so kind of fancy, but like, so people have a hard time thinking of big numbers. Right, when you're talking about infinity, you're talking about crazy big numbers, not like 500, not even 5,000. So the increase by a magnitude is like, you know, going from 10 to 1,000 or 1,000 to 100,000. That's increasing by magnitudes, okay? So, yeah, what Bryant said is really good, because this is a limit, and I'm going to write it as a limit right now. But they're basically talking about a limit here, but not telling you that we're talking about a limit. So this is the way that this is what they're really asking. So what is the limit of this function as x approaches infinity? And so this is part A. I'm going to do this one this way, and then. So, does anyone have an idea of like what we should do? So if it says x is approaching infinity, like what does that mean? X, like give me an example of what a good starting value for x could be.
Some really big number.
Well, it could be more specific.
100,000.
100,000. Okay, so, right, this is just a function. So if we plug 100,000 in for x, is this value being affected at all? No. Is this value being affected at all? Okay, so then really when we're doing this, we're only looking at this value here, right? So then what happens if, like, for instance, you plug in 100,000 to that value? What does it become? So really, really small number. And the bigger value of x you plug in, the smaller that number gets. And so that term, they say, is approaching 0. Good. Okay, so then this function is approaching 2. Because really what we have here is 2 plus 0, so this function is approaching 2. Is that okay? Okay, so then what's part B asking us then? Well, that's part C.
If it's positive, and where it's going to be.
Okay, so if we plug in, so it's approaching 2, it's not actually getting to 2. So if we're plugging in 100 million, positive 100 million, is this value really a little bit bigger than 2 or really a little bit less than 2?
Bigger.
Can you explain why it's bigger?
Because we're adding.
Because we're adding just a little bit more, but it still makes it bigger, right? Is that okay with everyone? This is limit stuff. This is what limits are about. That's why rational functions are such a big deal, because they have these situations going on where a lot of functions don't have these situations going on. So C is now we're plugging in a big negative number. So instead of positive 100 billion, now we can plug in negative 100 billion. So now are we a little bit bigger or a little bit smaller than 2? A little bit smaller, because that negative is making that 2 minus something. Something really, really small, but still 2 minus something. So it's not really 2, it's a little less than 2. Is that okay? These are cool problems. Cool problems, man. You're welcome, front row. I know you've lost even the guess of your name. You're just front row now. You can earn it back. You can come back and be Greg again if you want. You got a long way to go to get to Greg, huh?
I will move from the front row.
I was,
There's a seat right here.
I think that was pretty clever. I don't think of something like that. I only think of Cowboys and Sphinx.
All right, Cowboy and Smith, yeah. All right. So what's going on with this? You can think of this in two different ways.
Still gonna approach,
So he's saying it's still going to approach 0. So there's two ways you can explain why. So yeah, the answer is why f of x approaches 0. Can you explain one? Just do one way or one reason.
It's one reason why there's not because there's not another number that's not a fraction with x. Like this, the degrees are.
Okay. So yeah. So he's I know what you're saying, because you're saying like if I did this.
Yeah.
Yeah. Okay. So.
Approaching 3.
Okay, so you're kind of like a step ahead, though, in a way. Like what? Yeah, I know. All right, yeah, okay, so you just, yeah, he totally just moved to Greg now. Good job, Greg. Yeah. What? All right, so but why, Greg, maybe we can even get you a little further. Why is this 0, though?
Because they're both.
You
I know it, but I can't say it.
you can say it. Go ahead, say it. It's not a bad
They
word.
both have x in them.
They both have x on them. Good, true.
So the more, like, so if you change the value of x.
To something really big, like
Yeah.
100 billion.
They'll
Okay.
both be big.
They both will be big. So then.
That one will be.
Well, then you
The bottom one
combine
will be
them.
bigger, much bigger,
Okay, now he's saying much bigger. Why is it much bigger?
because it's doubled.
Well, no, it's not. Yeah, it's squared even, right? So like a lot, it's actually a lot bigger. Yeah, right. So like this, this ends up becoming like, what happened to my, right, this became infinity, but this one became infinity squared, which is much, much bigger. And so then like, basically like you can think of canceling in a way, even though this is cheating. All my YouTube peeps don't listen to this exactly, YouTubers. It's really just my kids. So this is how when they've been really good, I play this for them. Say hi to Jasper. Hi, Jasper.
Is that the same logic as playing like Mozart?
Yeah, that's correct. That is correct. Yeah.
Very
When they fall asleep, I just sneak in and I put my iPad in their room and just play it. Yeah. Okay, so then so anything divided by infinity is going to go to 0.
Yeah.
There is another way to explain it, though. Can someone do the other way to explain it? Something that we've already talked about today. Yeah.
There's nothing you can plug in for x to make it like be 0 in the denominator. Like,
Well, okay, so the function value is still going to 0 no matter what. So, like, I think you're just trying to say basically what we just said, but like, there's actually a significantly different way, but we've already talked about it today. It's 2 words. First word begins with H and rhymes with horizontal. Yeah, horizontal. Good job. Yeah. Yeah, you could just tell me by like the horizontal asymptote rules, which are what? Yeah, and so then that's why, yeah, so that's why the horizontal, so if you combine that with what? I don't know. We can go to, is that Gannon? He might be Gannon now.
I don't like it being Gannon. I'd be like.
Gavin, just we get the first 2 letters. All right, so okay, good, yeah. He's like prostrating himself in front of everyone. Look it up, it's a word.
Cross-training?
Prostrate.
I thought you said cross-training. I thought you meant like cross-training your brain for math. Like
Well, maybe he's doing that too, I'm not sure,
Like,
yeah.
like your brain is getting
Wow. So we could
I like math.
have got f of x equals 0 right away just by knowing that.
So yeah, here, listen, right? So he said we could have got f of x equaling 0 right away because we could have just applied the horizontal asymptote rules. And that's why the horizontal asymptote is at 0 because of what these guys are saying before. Because the denominator is growing so large that it doesn't even matter what's going on in the numerator. It's just going to be 0 because you're dividing by such a big number. But that's why those 2 things are the same difference. Yeah, pretty good, right?
Very cool.
Yeah, I'm impressed by you guys. I don't say that to every class, but I do say that to every class.
You don't say that to every class, every class?
Very cool.
I am not going to answer that with not a negative. If you can figure that out. Yeah, right. That was a triple negative for you guys keeping track.
Doesn't that mean that's just
I don't
positive?
know.
You got to figure it out. I am not going to not give you the reason that I did not say that.
Do we get our name taken away
So, I mean-
because I'm being
No, you do not.
Every time I get a question wrong on a test, we get one name taken away.
Or Rhonda.
Yeah, no, I do know your guys' names. That's true. If that's what you're asking. Was that what the question was? I lost track of the double negative situation, so. So, Randy,
Yes.
I will never not take your name away.
So you're gonna take it.
I won't.
It's a double negative.
I won't never not take your name away from you,
So you
okay?
will not take it away this time because 3.
Ever not.
Isn't this like math in disguise?
It is math in disguise. That's what's so awesome about it, yeah.
A double negative.
It's like music.
Actually positive.
Math in
Take your
disguise.
name away.
Have you ever seen my music theory notes? Because they really don't look like
I was
math.
just saying you'll never take your name away.
They kind of look like science.
Yeah, you'll never take your name away.
Gannon. Gannon's back. Woo! We lost him for a while. Good job, Gannon.
So if you say I
Always on a
won't
couple
never
minutes.
not 8 take
Yeah.
your name away,
That's right.
that means you will.
I was hoping
Probably.
this was a good time to
So I
say-
better pass the test.
I usually never count higher than 3, so I don't know. All right.
But we're talking about infinity.
That's right. You can't count to
But
it.
he didn't count
That's true.
it.
That's true. You cannot.
Ah!
It's infinity squared, that's only 2.
So if you put a minus sign in the sentence, never mind.
All right. So, okay. So let's do part B here. On this one, is it a little bit bigger or a little bit less than 0 if we're plugging in a huge positive number?
A little bit bigger, a little bit bigger.
Does anyone disagree with bigger? All right, what if we plug a really huge negative number in? Is it gonna be a little bit bigger than zero, or a little bit less?
I have a question. I'm confused, I just confused myself. Welcome to the club.
Well, okay, well,
Oh, but the
Is
negative
it still
would be on top.
okay, so hold on 1 second, Brian. So, okay, so is it a little bit bigger or a little bit less than if the negative's on top?
Less, because
It'd be
the
squared.
negative makes it the negative.
So, yeah, okay, so, right, so really, the top is a negative, and the bottom is a negative squared,
So we're
positive.
positive.
so it's a negative over a positive, so this would be a little bit less then,
So
right?
I was right for once in
You're-
my life.
I feel that's
Should be
it.
more proud that I'm right.
That's hyperbolic.
What?
Yeah, what do you got?
Okay, so if it's like.
Did I put my syllable in the right place? I don't know.
Decimal, that number's bigger,
Syllable.
what happens?
Say it again.
Like, for a decimal, like 5, would that be,
Where are you talking?
like, in the actual equation would be?
So like if it
In
was,
general,
so like you're saying if it was 0.5 x minus 1?
yeah,
Is that, or, well, plus, I don't care.
over x squared plus 1.
And we're still putting in really, so you're,
No, like x is 0.5. Yeah.
Wait, what's that?
He's saying
Oh,
x equals 0.5.
2 times
5.
0.5 and then 0.5 squared?
Yeah.
okay, well, but you're talking about something completely different
That
though.
still makes it.
Because if x is 0.5, we wouldn't be testing 0.5, right? Because that's not very big.
So it doesn't apply to that.
Yeah, so, but, if you're asking if you plugged in negative 0.5,
Yeah.
would you get the same thing? So it's kind of the same question. So this would be, but, where's your parentheses? So on the top, it's still a positive 0.5 times a negative 0.5, and on the bottom, it's still a negative 0.5 squared, so that still makes it positive, right? Is that okay? He lost interest, all right. Okay.
Yeah, it's okay. It
Is
just
that-
hurts my brain.
is that okay?
No.
He has a lot of things going on in his personal life.
Oh,
His
Very
girlfriend
cool.
broke up with him.
oh, no, really?
No, they're not dating, but friends zoned him.
She did, what happened?
She friend zoned him.
How did that happen? How does,
I don't know how.
See,
The problem is she likes him and he likes her, but she's still friends zoned.
We are still recording.
yeah,
Can we say goodbye?
should I stop? Should I stop?
Wait,
All right, this is just the first one that she had. So how do you solve this thing?
I'll say I'm gonna split it apart, so 3 over x and then 3 over 7.
You can't do that. You're thinking of if it was this, you could,
Oh, we have to just multiply and
or,
divide
is that what you're thinking? Yeah, so this could be, this. Okay, but we don't have that, okay.
Yeah, okay. Do you multiply x plus 7 on one side?
Okay, so like, can we do cross multiplication is basically what you're saying?
Yeah.
So then, right, so then we could go to this. Right?
Can you do that?
Yeah, we just cross multiplied there. And then you guys know what to do from there?